Hello friends, welcome to SSP Math. In last video, we already start Charpit method for solving the non-linear partial differential equation of order 1. So today we will take some problems on Charpit method. So first problem is solve p square plus q square is equal to x minus y. So what is our first step? This is the function of f of x, y, z, p and q. Means denote this by first f of x, y, z, p, q is equal to p square plus q square minus x plus y equal to 0, and from this try to write derivatives. That is, first one is dabba f by dabba x is equal to minus 1, second one is dabba f by dabba y equal to 1, third one is dabba f by dabba z is 0, फोर्थ डेरिवेटिव वी हैव टू फाइंड डैबा एफ बाय डैबा मीन्स एफ जिसका भी फंक्शन है ऑल डेरिवेटिव फाइंड करो. डैबा एफ बाय डैबा पी इज इक्वल टू 2p and dabba f by dabba q is equal to 2q. So these are the derivatives. Now by Charpit method we have to write subsidiary equation first. Now what is Charpit method? Charpit method is dx upon dabba f by dabba p equal to dabba dy upon dabba f by dabba q equal to dz upon p into dabba f by dabba p plus q into dabba f by dabba q equal to dp upon minus into dabba f by dabba x plus p into dabba f by dabba z and equal to dq upon minus in bracket dabba f by dabba y plus q into dabba f by dabba z. So we have to put all values here. So first one is, this implies dx upon what is dabba f by dabba p. So here dabba f by dabba p is 2p is equal to dy upon dabba f by dabba q is 2q is equal to dz upon p into dabba f by dabba p is 2p plus q into dabba f by dabba q is 2q equal to dp upon minus dabba f by dabba x is minus 1 plus p into dabba f by dabba z is 0 equal to dq upon minus in bracket dabba f by dabba y is 1 and plus q into dabba f by dabba f is dabba f by dabba z is 0. Now here we can choose group. You observe this carefully. Dx upon 2p is equal to dp upon 1, or we can take also dp is equal to minus dq. Okay, so we can choose here group. Choose group dx upon 2p is equal to dp upon 1. Okay, so how we solve this differential equation using variable separable form? So dx is equal to 2p dp. If we take integration here, then integration of dx is x, integration of this term x is equal to 2 into p ka integration p square by 2 plus constant of integration a. That is, using this we can write this 2 get cancel, p square is equal to x minus a. So we want the value of p. So what is p? P is equal to under root of x minus a. This is our equation 1. Now how we find q? Put the value of p in, means put this p in equation 1. Equation 1 is p square plus q square equal to x minus y. So put in 1. now 1 क्या है? p स्क्वायर है. p स्क्वायर मीन्स रूट ऑफ x माइनस ए का स्क्वायर क्या हो जाएगा? x माइनस ए प्लस q स्क्वायर इज इक्वल टू x माइनस वाई. सो दिस x गेट कैंसल. यूजिंग दिस वी कैन राइट q स्क्वायर इज इक्वल टू, इस माइनस ए को इस साइड मिले तो प्लस हो जाएगा a माइनस वाई एंड देयरफॉर q इज इक्वल टू अंडर रूट ऑफ a माइनस वाई. सो दिस इज द वैल्यू ऑफ q. दिस इज द वैल्यू ऑफ p. देखो इस प्रॉब्लम में हमें डायरेक्ट p एंड q इन टर्म्स ऑफ x y z मिले. सो वी हैव टू पुट दिस p एंड q, पुट इन p एंड q in which equation? dz is equal to p dx plus q dy. So is equal to, what is the value of p? P is under root of x minus a into dx plus q is under root of a minus y into dy. This is dz. Okay, so we have to take integration here For integration we will write one more step here. Integration of dz is equal to रूट का इंटीग्रेशन थोड़ा कॉम्प्लिकेटेड जाता है बहुत सारे लोगों को, तो इसको मैं ऐसे लिखता हूँ x माइनस ए टू द पावर हाफ इंटू डी एक्स इंटीग्रेशन ऑफ प्लस इंटीग्रेशन ऑफ सेम दिस a minus y to the power half into dy plus constant of integration take b say. Okay, so integration of dz is z is equal to its integration is x minus a raised to half plus 1 that is 3 by 2 upon 3 by 2 and plus इसका इंटीग्रेशन क्या आएगा a minus y raised to 1 by 2 plus 1 that is 3 by 2 upon इसका डेरिवेटिव minus 3 by 2 plus b. So this is the required solution of given partial differential equation using Charpit method. So next problem is solve p square y plus q square y is equal to qz. So again our first step is denote given differential equation by f of x y z p q is equal to p square y plus q square y minus qz equal to 0. So here again f is function of x, y, z, p, q. So we have to find partial derivative of f with respect to x, that is del by f by del by x is 0 here. Then with respect to y, del by f by del by y is p square plus q square आएगा. Del by f by del by z is with respect to z के लिए minus q. Del by f by del by p is 2py and del by f by del by q is 2qy minus z. इसका डेरिवेटिव 2qy minus z. So these are the derivatives of f of x, y, z, p, q with respect to x, y, z, p and q. Now by Charpit method we have to write subsidiary equation. That equation is dx upon del by f by del by p equal to dy upon del by f by del by q equal to dz upon p into del by f by del by p plus q into del by f by del by q equal to dp upon minus into del by f by del by x plus p into del by f by del by z equal to dq upon minus into del by f by del by y plus q into del by f by del by z. So put all partial derivatives in subsidiary equation. Then we will get here dx upon what is the value of del by f by del by p. Del by f by del by p is here 2py equal to dy upon del by f by del by q is 2qy minus z is equal to dz upon p into del by f by del by p is 2py plus q into del by f by del by q is 2qy minus z is equal to dp upon minus in bracket del by f by del by x. What is the value of del by f by del by x? 0 plus p into del by f by del by z is minus q. Okay, equal to dq upon minus in bracket what is the value of del by f by del by y, that is p square plus q square. Del by f by del by y is p square plus q square plus q into del by f by del by z is minus q. So this q square minus q square get cancelled, means p square here. So which group is possible here? Can we take dx upon 2py equal to this? No, because y is present here. If we take dy upon this, again z is problematic. So here if you observe dp upon minus minus plus pq, dp upon pq equal to this q square get cancelled here, dq upon minus p square, means ये जो group है in terms of p and q है. So choose group here dp upon pq, ये minus minus plus हो जाएगा, is equal to dq upon, देखो ये q square and this q into minus q square, minus q, that is minus q square plus q square get cancelled, minus p square. So 1p get cancelled. And how we solve this differential equation by variable separable form? हाउ वी सेपरेट वेरिएबल्स बाय टेकिंग क्रॉस प्रोडक्ट लिया तो क्या आएगा P dP is equal to minus Q dQ. How we solve this differential equation by taking integration. So what is the integration of P dP? That is P square by 2 is equal to integration of minus Q is Q square by 2. Suppose constant of integration is A square by 2. Okay, so we will get here P square plus Q square is equal to A square. डायरेक्टली वैल्यू मिली हमें बिकॉज इससे आप P भी लिख सकते हैं बट हियर इफ यू टेक Y कॉमन देन वी विल गेट डायरेक्टली P स्क्वायर प्लस Q स्क्वायर एंड वी वांट Q फ्रॉम दैट सो P स्क्वायर प्लस Q स्क्वायर इज इक्वल टू A स्क्वायर नाउ वी हैव टू फाइंड द वैल्यू ऑफ Q बाय पुटिंग 1 सो पुट P स्क्वायर प्लस Q स्क्वायर इक्वल टू A square in equation. So P square plus Q square equal to A square, put in 1. So first we will write here equation 1. Equation 1 is P square plus Q square into Y is equal to QZ. Okay. So this is equation 1. If you put P square plus Q square is equal to A square here, then we will get A square Y is equal to QZ. So using this we can write Q is equal to A square Y upon Z. So this is the value of Q in terms of X, Y, Z. Now we have to find P. So how we find that P? Put the value of Q here. So we know that here now P square plus Q square is equal to A square and therefore P square plus Q square क्या आएगा A raised to 4 Y square upon Z square is equal to A square. So using this we have to find P. So try to find P from this. So P square is equal to A square minus A raised to 4 A square minus A raised to 4 into Y square upon Z square. So if you take LCM Z square here, then this becomes P square is equal to A square Z square minus A raised to 4 Y square upon Z square. Take square root of both sides. Therefore P is equal to, यहाँ से हम A square कॉमन ले सकते हैं, उसका स्क्वायर रूट A आएगा और अंडर रूट में क्या रहेगा Z square minus A square Y square upon Z. So this is the value of P. Okay, and after getting P and Q, what is our next work? We have to put that P and Q in dz is equal to P dx plus Q dy. Okay, so this is equal to P is then A into under root of Z square minus A square Y square upon Z into dx plus Q is A square Y upon Z into dy. Okay, so we have to separate variables here, multiply both sides by Z and therefore Z into dz is equal to A into under root of Z square minus A square Y square into dx plus A square Y dy. Okay, अब देखो ये मिक्सिंग फंक्शन है. फॉर सॉल्यूशन ऑफ द डिफरेंशियल इक्वेशन वी हैव टू सेपरेट वेरिएबल्स. Here Z square minus A square is, so write down all terms of Y and Z in one side. Try to write. So here Z dz minus इस A square Y dy को हम LHS में ले रहे हैं is equal to A into under root of Z square minus A square Y square into dx. Okay, and therefore dx is equal to, or this keep A dx as it is. We have to separate variables. A is constant, keep as it is, and Z and Y की term इस side में लो, so is equal to Z dz minus A square Y dy upon under root of Z square minus A square Y square. Okay, so take integration here. If you take integration, then integration becomes A into integration of dx is equal to integration of Z dz minus A square Y dy divided by under root of Z square minus A square Y square. So we know one formula, integration of f dash of x upon root of f of x is equal to 2 times root of f of x. So use this formula here, 2 times root of f of x. If we take this function say f of z और कुछ भी हो, इसका ये डेरिवेटिव आता है क्या? देखो z स्क्वायर का डेरिवेटिव क्या आएगा 2z dz. सो वी वांट हियर 2z dz. ओके, एंड माइनस A स्क्वायर Y स्क्वायर का डेरिवेटिव क्या आएगा माइनस 2A स्क्वायर Y dy. सो यहाँ पर 2 मैंने एक्स्ट्रा लिया तो 2 ने डिवाइड करो. अभी मिला f डैश अपॉन रूट एफ फॉर्म, f डैश अपॉन रूट एफ इज 2 टाइम्स रूट एफ, सो इंटीग्रेशन क्या आएगा 1/2 इंटू 2 टाइम्स अंडर रूट ऑफ जेड स्क्वायर माइनस ए स्क्वायर वाई स्क्वायर and in LHS ax. So this 2 get cancel. Answer is x is equal to 1 by a, this 1 by a into root of z square minus a square y square. So this is the solution of given partial differential equation of order 1. Now you take homework. Homework's problems are very simple here. First problem, you try this. That problem is, so that problems are, first one is p is equal to 2x q square, you try this at home, and second one is 3p square minus q equal to 0. So try these two problems at home. Thank you.